All right, now we've got part one out of the way, implementation plan behind us, coding behind us. We now have a base foundation for the precision game sitting on the hard drive waiting for us to add more code. So let's go ahead and come over here to our implementation overview, and we'll go ahead and circle that guy because he's now done. Let's go ahead and jump down to part two. So in this video, once again, an implementation plan, but focusing on a very specific section. That section is the game class basics, if you will. Something that you have seen us set up over and over again in a lot of the examples that we've given throughout the XNA Xtreme class. Things like establishing a resolution, getting a sprite batch in place. We're also going to set up a random object. We've done that several times in the past. And of course, there's a few extra things we're going to be doing, such as defining our game states or making sure that the background is drawing by the very end of the video so that we feel like we have something cool taking place. We want to see something by the time we end part two. Now, there are some other things that we're going to be doing as well. We are going to do a little bit of work inside of update, such as getting our game state switch statement in place so that we can start switching between game states. We're also going to do the same thing down in draw. We're going to set up for receiving input from our gamepad in update, and we're going to loop through all of our actors in update and call upon each actor's update method. And over in draw, same thing. We're going to loop through all of our actors, and we're going to call on, well, actually, we're not going to loop through them. Let me not get too far ahead. We're simply going to call draw actors, which is a static method, which will loop through all of the actors and draw them. Whew, a lot of looping here. I think it's going to be a little easier to see what I'm talking about if we start the true implementation plan. So let's do that. Let's go ahead and jump over here to the whiteboard. Go ahead and hide this, cruise on up to the top, and create a new layer. Well, thank you very much, Photoshop. Let's just drop that up here. There we go. Now, with this guy right here, what do we want to show? What do we want to show? Let's start out with part two. That's what we're focusing on. Once again, game class basics. So, first thing we're going to do is we're going to set up a couple of internal constants that are simply going to hold the screen resolution. So we're going to have a screen width and a screen height. A screen width set to 800 and screen height set to 600 because that is the resolution we're looking for our game to be.
Right. The other thing that this will let us do is to define these as constants. Kind of makes them like what I would consider to be properties of the game. So an easy, actually the very first area you'll notice inside of the game class. So we can not only use these values to turn around and set the screen resolution, but since we have these established, we can always look back to them when we're trying to define what the screen bounds are. So if anything needs to be positioned at a specific point on the screen or percentage of the screen, we can always look back to these values to use any type of screen dimension calculation that we need.
Exactly. So here we are with the screen height.
And that gives us screen width and screen height.
And once again, we'll just set up 800 by 600. All right, once we have that in place, what we're going to do is jump over to the constructor, and we're going to add in the graphics.preferred back buffer width and height and set those equal to the screen width and screen height constants so that we do indeed make sure that our resolution is properly set.
Right. And the reason that we're going to be setting these in the constructor, of course, is since the graphics device itself has not yet been created, we'll establish these as properties in the graphics device manager, so later, after run is called, that these values will simply be taken into account. What this means is that we don't ever have to hit apply changes to the graphics device.
Right.
Since we were actually establishing these before the graphics device is even created.
Exactly. So once we're done with the constructor, what we're going to do next is create the sprite batch. We've seen this a lot.
Well, since this is a sprite-based game, we will need something that can draw sprites. And the sprite batch will work very well for that.
So we'll make sure that we declare the field as well as create the object. From there, another thing that we've seen several times, we're going to create a random object, but this is going to be a static random object.
Right, and we'll get into the specifics of why it needs to be static later when we use, I think, some of the enemy code in conjunction with it. But the idea here is that several aspects of the game are based on random values. We have random placement of enemies and cells, and we also have randomized amounts of time that the enemies use to move around the screen.
Precisely.
So a few things are going to require access to random values, and we'll get those from a random object.
Once we have the random object set up, the next thing we're going to do is start working for just a second on the game states. So first thing we're going to need is a game state enumeration that's going to set up our title, level change, playing, died, and game over elements of game state. So let me just go ahead and jot down an enum. for game state.
Right, we've already discussed what the game states need to be, but here we need to define them so that we can easily access different states and define what the states actually are.
Precisely. So, and once again, title, level change, playing, died, game over. I just don't want to write all that. From there, next thing we'll do is we will go ahead and define a field that is going to hold the current game state. So I'm just going to call it the game state field.
Right, this will be a field for the game itself, so that the game always holds a specific state. And that will, of course, be of type game state, so that anytime we check it, it can be one of the 5, title, level change, playing, died, or game over.
Exactly. And now, even though we're not truly using game states yet, we're going to go ahead and set the foundation of it up. And what I mean by that is we're going to go ahead and initialize our game state variable by setting it to game state.playing. So if we were indeed using game states, basically when we test our game, each time we build and run it, we would be in a playing game state, just so that we immediately jump in and can see things moving around or can control a character. We don't have to want to worry about a title screen, a level change, things like that. That'll become important later on when we start sprinkling in the actual code rules or the game rules of the game itself. So again, just a foundation in place. So in initialize, what we want to do is take game state, go ahead and set it to playing, and then in update, we're going to go ahead and put that switch statement in place and make that switch recognize the different game states that the game can be in. So let me go ahead and jot down the game state here.
Right, the idea is that we want to make sure that we code our game around the idea of game states from the ground up. But we don't want to have to code absolutely every aspect of the states in, meaning screens and input for changing screens. So what we're going to do is kind of a compromise. The code will be based around the game state framework, but it's going to be set to playing by default, so that way, even though there were multiple states handled, right from the beginning, we start at playing, so that for the first few lessons when we're doing individual classes, everything will just begin in the playing state.
And while you were talking, I figured I'd just go ahead and throw this in. We'll set this up and initialize. All right, so once we have that out of the way, that pretty much takes care of the first half, well, actually over the first half of the game class basics setup, and this allows us to focus on the update method and the draw method. So let's go ahead and take a look at what we're going to do inside update. We are going to begin by first creating the switch statement that will use the game state to decide, well, what piece of code is going to need to be executed. And of course, each piece of code will be relevant for that particular game state.
Right, it's as though we want to break update down into more specific sub-update routines, because depending on the state of the game, we want different things to update. And in cases where things will only update within a specific state, that means we only want certain things to update under playing, because we don't want gameplay elements to update when we're at a title screen or any other screen.
Right.
And that will also enable us to have things set up so that once the player dies, we stop updating the scene. What's cool is the scene will still exist in its current state, so we can still draw it, but that'll give the pause style functionality when we switch states out of the playing. Okay.
Next, what we're going to do is we're going to go ahead and get input in update. We're going to go ahead and get ready for handling all of our input. So we'll basically store our gamepad state.
Right. There's going to be several different things that are going to require input. Those are things like changing screens and player input. So we want to have the gamepad state stored and ready for use in whatever state needs it. So we'll set up a gamepad state and then capture the gamepad state using the get state. That just prevents us from having to do a lot of calls to get state over and over again.
Right. Okay, so once we have that in place, the next thing we're going to do is our first loop. At some point, we're obviously going to need to call on every actor to update itself. And we've already seen when setting up the skeleton that each actor does indeed have an update that's virtual, and then that update gets overridden based off of what kind of actor it is. So let's go ahead in this section here and set up the loop that's going to walk through all of the actors, causing each of them to have their update executed. Now we're going to do this in a certain way. First of all, let me just jot down actor update. In fact, I'm going to call it actor update loop. Now, let's take a look at this. Here's a list. And inside the list, we have actors. And we know these actors can be player or a player. It could be cells. It could be enemies. Let's start walking through it. We call on this guy. We tell him to do his update. We call on this guy. we tell him to do his update. We call on this guy, we tell him to do his update. Now let's follow that through. So here we are in a little fuzzy world. This guy happens to be a cell, and he was right at death. So inside this fuzzy update, he died. Well, what happens when the cell dies? He needs to be removed from the list, because to have him in the list, that wouldn't be efficient for us to have to go back through and call on a dead cell to update itself because it's dead. So we need to remove this guy. Well, what happens with all of the elements that are in the list when we remove an element out that's somewhere in the list? They all shift downward. So this guy right here is going to go into that position. Okay, I know that might be a little hard to see. I'll darken in the arrow. So he's going to move to that position. This guy is going to move to that position. And this guy is going to move to this position. So they all shifted up one. That's fine and dandy. Let's say that we're now done with our little cloud execution over here and we return back to the loop. What's the very next thing that's going to happen? We're going to advance to this guy. Well, the guy that was originally here has now shifted up to right here. So this guy that we're now addressing was really this guy just a second ago. We skipped this guy. We've seen this all the way back in the list lessons that we gave earlier. Now, this may look like, well, that's a big problem. Well, how do we fix it? Well, there's a few different ways. One, if a case comes up where we've just removed somebody out and everybody has moved like this, well, we need to start thinking about the index that we're pointing at, because it's going to automatically move up one, and if we subtract one away, we're pointing at the right guy. Bit of a headache, huh, Logan?
Right.
It's just extra work.
Right, it's extra code that would have to be put into account for that, because we need to actually take the index and make it take a step back so that we continue at the next actual actor.
So another way that we can do this, and we've seen this before, so you can think of this kind of as a review, is we can run the loop in reverse. So we can start at the last guy, deal with him, call upon him, he takes care of his own update. We can call this guy, he calls his own update. Now let's say we call this guy, he calls his update, and out here in fuzzy land, it's a cell that's just died, so he gets removed. Well, what happens? This guy is going to shift up, this guy is going to shift up. Now, we continue. But we continue with this guy. We've already dealt with this guy before, who is now sitting in this position, right? So it's irrelevant. It works beautifully. So we continue to run the list, but we run the list backwards, and we don't have the risk of skipping anybody or running outside of the bounds like this.
Right, because what it comes down to is no matter what you try to do, whenever you remove something from a list, if you remove it from the beginning or middle, basically if you remove anything other than the last item, the indices are going to shift. You'll never have a gap in a list.
Right.
Well, what walking backwards does is make it so that when that shift occurs, it occurs into a spot that we're already done with. So the shift occurs, but we keep walking away from the shift, so it never affects us.
Exactly. I'm just adding a little bit to my notes here. Reverse loop. So we're going to do an actor update loop, but we're going to run the loop in reverse, and then all we're going to do is simply call on each actor that's stored in the actors list, call on it to have its update executed. That's all. So once we have this done, then we're going to go ahead and shift our attention over to the draw method. Let's take a look at what we're going to do in the draw method. First of all, let's give myself just a little bit more whiteboard. All right, we're not doing that many things, but first thing we're going to do is we're going to make sure that we have a switch statement set up to deal with game state. So I'm going to go ahead and say game state switch statement.
Well, this is a case where, once again, we need to have different possibilities that will occur depending on what state we're in. Because if you think about it, if you're in a title state, you'll see something different than if you're in a playing state. So inside of draw, we need to make that decision and decide what needs to be drawn based on the game state.
Okay, and then after we get that in place, let's go ahead and do some background drawing. So we're going to need to set up another field. So I'll go ahead and just jot that down here. And we don't need to set this field up at the very beginning because it really won't make a lot of sense. So when we get ready to draw the background, then we'll just go back in and we'll set up a texture 2D that's going to hold our background texture.
Because I think actually for all the texture fields, they are going to be added on more of a as needed basis.
Yeah, and that's fine.
Whenever we implement something and then need a texture for it to draw, we'll add that field into a section up at the top of the game class.
So we'll go ahead and get that set up, and then we'll draw it. Easy as that. Now, once we have a background drawing, one final thing is we know that all actors that exist need to be able to draw themselves to the screen. All the enemies need to draw themselves, all the cells need to draw themselves, the player needs to draw himself, and the bars need to draw themselves. We'll get to bars later, of course. So right now, actor, what we're going to do is we're going to call on that static method draw actors that's inside of the actor class. And if you recall, that static method just simply turned around and called each of the actors draw method.
Right, and what that does is make it so that we don't have to have a loop inside of draw.
Right.
Since draw is going to be just a simple draw for all, we're going to have a method, that loop actually stored back in actor, so that our code in the game class is less cluttered. That way we have this code off to the side in the draw actors method, and we simply call upon that from draw. So that way, drawing all the actors is a one-line call from the draw method.
And that's it. This is the goal for part 2 of precision. So if by the very end of this section, in the next video, we have our screen resolution set up and being set properly, a sprite batch in place that we can use to draw out the background, the random object in place, our game state enum set up, and we've got the switch statements in place in both update and draw, and we're looping through our actors and calling their update, and we're calling upon the actor.draw actor static method, then we've got everything in place. So with that, is there anything you want to add to this, Logan?
No, I think that covers all the points we need to hit for getting the game state set up and the game class.
Okay, so let's go ahead and jump into the next video and code all of this out.